Solving systems by graphing. What is a system and how do you solve it by graphing? Well, first we have to remember a couple of things. Let's remember what we know about a line, that a line represents all the solutions to an equation. So all the ordered pairs that we could find that will solve that particular equation will be found on the line. Now, when we're dealing with a system, we're basically talking with more than one line. So with a system, we're looking for the common solution to a set of equations or multiple lines. So as we look at this diagram here, we can see that they collide right here in this spot, and this spot represents -1, +3. That would be the common solution or the solution to the system where the lines collide. Now, we can solve for this, first off, algebraically, and see if a certain point is a solution. In other words, when we're looking at these two equations, is this point 3, 5 the solution? Is this where these lines collide? So let's take a look, and we remember that this is x and this is y. So we're going to plug them in and replace them for the right number. So here we go with this first one. 5 equals 4 times 3 minus 7. We're going to do our order of operations. So 4 times 3 is 12. And 12 minus 7 is 5. So far it checks out and it is a solution to the first one. Let's apply it to the second one here. 3 plus 5 equals 8. And again, we can see that it is a solution. So it's on both of these lines, so it must be where they collide. So yes, it is a solution. Let's practice a few more times. Here we have an x and a y, and we're going to plug it in and see if it works. So we just got to make sure we're putting them in the right place. 2 equals 1 plus 1. Well, 2 does equal 2, so far that's looking very good. Here we're going to have 2 times 1 plus 2, and 2 times 1 is 2, and 2 plus 2 equals 4. So again, this works out, so yes, it's a solution. Let's try it one more time and practice and see if a particular point is a solution. So we're going to take this again with the x and y, and we're going to plug it in. And every time that the equations, doesn't matter if the y is on one side, it's on the other, we're just going to plug in and replace the variables and see what we get and see if it's true. -2 times 2 is -4. -4 minus 1 is -5. So far it's working out. Check the other one. 3 times -2 plus 2 times 1. Does that equal 3? Well, 3 times -2 is -6. 2 times 1 is 2. -6 plus 2 is 4, and that does not equal 3. So it's not a solution to this. So is it the common solution? No, it's not. Now, let's say you had started with the second equation first. If you found out that it was not a solution to that particular equation first off, then you could have stopped right there because it needs to be a solution to both. Now let's practice a little bit of graphing. And here we have two equations, x plus y equals 3 and x minus y equals 1. I want you all to remember the slope-intercept format. If we can get the equation into this format where the y is by itself on one side and the other numbers are all on the other side, we're able to find two things. We'll be able to look at the equation, look at the value that's next to the x, and know that that's the slope of the equation, the rise over the run, the angle of the line, and we know that slope is a fraction. Also, we'll be able to see the number that's sitting by itself. We know this to be the y-intercept. The y-intercept is where the line is going to cross the y-axis. So let's take this first equation here, x plus y equals 3, and let's manipulate it so that we are in that slope-intercept format. So in order to do that, we'll subtract an x from both sides. That way we end up y equals -x, and this is a positive 3, so that we're in the right format to match this over here. Now, based on that, we can gather some information. We can find the slope, and we can find the y-intercept. We know that the slope is found with the x, and here we have a negative sign, which means that it's going to be -1. We also know slope is a fraction representing rise over run, so we'll put that over 1. This 3 will then represent the y-intercept. So when we go to plot this, we'll find positive 3 on our y-axis, and from there, we will move or follow our slope of going down 1 and to the right 1. And then we're going to draw ourselves a line and connect our points. I get a blue line here. And we want to extend our line all the way through, just in case, because we don't know where the other line is going to cross at. All right, and now we're going to work on the second equation down below here, x minus y equals 1. And once again, first thing we're going to do is we're going to start to isolate that y by subtracting an x from both sides. We get a negative y equals negative x plus 1. Now this is telling us that the opposite of y is equal to the opposite of x plus 1. We don't want the opposite of y, we want what y equals. So in order to get negative y to become y, we can multiply or divide it by negative 1. If we do that, we must do it to all of them because we want the opposite of what everything is, because this told us what the opposite of y is. So therefore we'll have a positive x and we'll get a negative 1. Based on this information here, we can find out what our slope is and what our y-intercept is. Again, looking here, our slope, there would be a 1 in front of the x there, so that would be 1. And we turn that into a fraction by putting it over 1 as well. Our y-intercept is negative 1. So we go to our y-axis and we'll put a dot at negative 1. And the way we will move is our slope. We're going to rise over run. So we'll rise one box, run one box. And you'll see that they'll collide. So we're going to draw our line through these points here. And we're not done yet because remember, this is all about finding a solution. And where they cross, right there, that's our solution. So our solution to this problem then would be positive 2, positive 1. This would be the answer that satisfies both of these. We'll try it one more time. This time we'll have y equals 3x minus 2 and 2x plus y equals 3. We'll start with this first one, already in slope-intercept format. So all we have to do is get some information. Find out what the slope is and what the y-intercept is. We know the y-intercept does not have the x with it, so we'll put that right there because it is a point. It's a location on the coordinate plane. Slope is always next to the x, so we're going to put that right there with 3, and we need to turn slope, which is a number, into a fraction, rise over run, so we'll put it over 1. We'll go to our graph at negative 2, and then from there we will rise 3, 1, 2, 3, and run 1. From there we'll draw our line and we'll connect our points. I'm going to straighten my line out a little bit. Okay. Now let's continue. Let's take the second equation here, which would be 2x plus y equals 3. And let's begin to isolate the y. We'll subtract 2x from both sides, and we get y equals negative 2x plus 3. Again, we're going to look at that, and we're going to get our information. We're going to get our slope, and we're going to get our y-intercept. Our slope is always with the x and is a fraction, so we're going to put negative 2 divided by 1, our rise over our run, and the number that's out there, that is our y-intercept. And that's positive 3. So we'll go to positive 3, make our point, and then from there we'll run down 2 to the right 1. Because you can see we're going to run into the other line. So we're going to draw our line to go through those points. And then this is our solution to our system of equations, which happens to be 1, 1. Hopefully this will help you understand a little bit more about how to solve systems by graphing.